Hello everyone. We Prakash, Vyshnavi, Shruthi, and I are explaining the Kruskal's algorithm and its application in minimum spanning tree. Let's get started. Okay. Before we get to that, there are some basics which we shall look into now. There are three topics: what is a tree, what is a spanning tree, and what is a minimum spanning tree. Okay. Tree. Now, tree is basically a graph which has two properties. One, the graph is connected, and two, it is acyclic, and that is it. Spanning tree. A spanning tree is a subset of a graph which has all the vertices covered with minimum possible number of edges. Hence, a spanning tree does not have cycles and it cannot be disconnected. By this definition, we can draw a conclusion saying that every connected and undirected graph has at least one spanning tree. There are few properties here which make up a spanning tree. As you can see, the following bullet points state conditions required to make a spanning tree. One can look at these points as it is straightforward. I will mention a few points here. 1. A spanning tree doesn't contain cycles, meaning the graph cannot be one loop. 2. Spanning trees have n-1 edges. N is the number of vertices, and so on. Now, first fundamental topic to cover before getting into the algorithm is the minimum spanning tree. Now, minimum spanning tree is basically a spanning tree which with the minimum amount of weight compared to all the other spanning trees which can be made from a particular graph. Now, as you see in these diagrams here, the spanning tree has a cost of 11 in this middle diagram. When we follow the path of the weight 4, 5, and 2. Whereas once we follow the path of the minimum weight here in this third diagram, it being 4, 1, and 2, the cost comes up to 7. So the minimum weight covered in the spanning tree is called the minimum spanning tree. And as it's mentioned here, the number of edges of a MST, which is a minimum spanning tree, is mentioned here. It is V minus 1 edges, V being the number of vertices. And now Shruthi will take over and explain about Kruskal's algorithm.
Prakash.Y algorithm is a minimum spanning tree algorithm which takes a graph as the input and it finds a subset of the edges of that graph which forms a tree that includes every vertex, has the minimum sum of weights among all the trees that can be formed from the graph. Now this Kruskal's algorithm basically falls under a class of algorithms which is called greedy algorithm, and this greedy algorithm finds a local optimum for finding the global optimum. We start from the edges which has the least weight and keep adding the edges till we reach our final goal. Now let's go through the steps of the algorithm. First step is you'll have to create the edge list of whatever graph that is given with their weights. Second step, sort the edge list according to their weights in ascending order. Third step is to draw all the nodes to create a skeleton for the spanning tree. Fourth step is to pick up the edge at the top of the edge list, which is basically the edge which has the least weight. Fifth step is to remove this edge from the edge list. Now sixth step or the last step is to basically connect the vertices in the skeleton with the given edge. If by connecting the vertices a cycle is created in this skeleton, then we have to discard this edge. Now repeat steps 5 to 7 until you get n-1 edges or list of edges is over. Now Prakash will explain the algorithm with the help of an example.
You would have seen what is Kruskal's algorithm and how it works. Now let me explain you how to compute a minimum spanning tree using the Kruskal's algorithm with an example. This is going to be the graph for which we are going to construct a minimum spanning tree. So what we are going to do in Kruskal's algorithm is we are going to keep including the minimum edges as long as no cycles are formed. Once we cover all the vertices, we stop. This is how it goes. So let's start. The very first step is removing all the loops and the parallel edges from this graph. Parallel edges means from one vertex to another vertex there would be two edges. If you see in this graph from A to B, you would find two edges. One edge has a weight of 9 and the other 3. So these are called parallel edges. We are supposed to remove any one of these. We must keep the one which has the minimum weight associated and remove the other. So in here we will remove the edge with the weight of 9. Suppose from a vertex we have a edge to the same vertex, then we call it as a loop, like we do in vertex C in this graph of weight 1. So we will remove it too. Now the next step is note down the weights of the edges and we will arrange them all in increasing order according to the edge weight. This is the order in which we are going to add the edges to the minimum spanning tree. Now let's start the construction of the minimum spanning tree. Firstly, I will add the edge BD which has the least edge weight of 2 to the minimum spanning tree. Now add the edge DE to the minimum spanning tree which is the next shortest edge. Add the next shortest edge which is edge AB with weight 3 to the minimum spanning tree and then check whether any cycle is being formed in the tree. If yes, then discard that edge and move on to the next edge. In here, it doesn't form any cycle, so we will leave it as it is and move to the next edge. Now we will add the edge AC with weight 3 to the minimum spanning tree since after adding it there is no cycle being formed. Next we will check the edge BC with weight 4. Since after adding it a cycle is formed, so we will discard it. Similarly, keep on adding the edges to the minimum spanning tree until the edges after adding forms a cycle. Finally, we have covered all the edges and connected all the vertices to each other. Now we can stop. Now we should check whether we have fulfilled Kruskal's algorithm's procedures of computing a minimum spanning tree. Firstly, the tree should not contain any cycles. Secondly, the graph had 6 vertices and our tree must contain 6 vertices too and 5 edge, that is n minus 1 edges, and our tree satisfies both these Kruskal's algorithm's procedure. So this is our minimum spanning tree of the following graph. The cost of the minimum spanning tree is we will add all the 5 edges and which gives 17. So 17 is the cost of the minimum spanning tree which is minimum among all the other spanning trees we could have formed. Now I will show how the code is being implemented for Kruskal's algorithm in C language.
Okay, now let's look into the complexity of Kruskal's algorithm and the time complexity. So now the time complexity of Kruskal's algorithm is O of E log E and O of E log V, where E is the number of edges and V is the number of vertices. Now let's understand how we got this complexity. It's been mentioned that we used the find union algorithm. So once we iterate through all the edges and apply this algorithm, uh, we get at most that the time for find and union operations is O of log V. So the overall complexity is O of E log E and E of log V. The value of E can be at most O of V times 2. So here we can say that O of log V and O of log E are both the same. Hence we got this complexity of O of log E, O of E log E or O of E log V as the time complexity of Kruskal's algorithm. Now Vyshnavi will be explaining the applications and conclude our presentation.
Thank you, Haripreeth. Okay, now let's think about where this Kruskal's algorithm is used. So depending upon all the stated points above, we can have a comparative idea of choosing an algorithm for a particular application that we use generally in our real life. Firstly, it is used in Google Maps, like it selects and shows the shortest or minimum path to reach our destiny. So here time taken is also very less, and also used to design a road network by small outlying villages. Next, in order to lay out electrical wiring and network design. Suppose you have a business with several offices, you have to lease phone cables to connect all these offices. So you can make use of this algo to find out what is the minimum cost to connect all your offices with minimum use of phone cables. And in electrical grid, they are also often used in computer networking. For example, if you have a large LAN with many switches, finding an MST will be vital to ensure that only a minimum number of packets will be transmitted across the network. And then used in network of pipes for drinking water of natural gas, as well as irrigation channels. Also used in single linkage clustering, which is also known as nearest neighbor clustering. Here we use this algo to choose the nearest element. So, finally, let's conclude this here by giving a quick revision. We came to know that what is Kruskal's algorithm in data structures and its working. It draws the idea of MST algorithm and gives the workflow push system based on position, which is also called as a greedy algorithm in graph theory. On basis of working in each step, it adds the next lowest weight edge that will not form a cycle to the MST. And this algorithm was written by Joseph Kruskal in 1956. It is faster for the sparse graph in which the number of edges is much less than the possible number of edges. Kruskal performs better in typical situations and is easier to implement because it uses disjoint sets and simpler data structures. By this, it is concluded that the selection path of this algorithm is more accurate and stable and has the advantage of time. Additionally, you also learned how to build an MST for a given graph using Kruskal's algorithm. And also, we saw how to develop this algorithm and code using the C programming language. Finally, we ended with applications of Kruskal's algorithm. Hope you were understood. Thank you for being here and listening to the video.